Good afternoon and welcome to today's lesson. I'm going to do a 2024 Geography Paper 2 for November. I'm going to concentrate on Section B, which is part of our Mapwork. I always encourage that whenever you are doing Mapwork, you are supposed to start by going through the general information of the area under study. In this instance, we have got the general information of Bloemfontein. I'll read. Bloemfontein is the capital city of Free State. It is located in central South Africa on southern edge of Highveld. The area is generally flat with isolated hills, although agriculture is the main primary activity. Business mainly drive Bloemfontein's economy. Due to many businesses, it has attracted more people into the area. This has led to many new development. So this part is very important because you need to familiarize yourself with the area under study, which is covering your map. So which is covered by your map. You need to go through this information. It's very important. So our first part now is we are going to go through map skills and calculations, which is part of our 3.1 map skills and calculations. That's what we are going to go through first, map skills and calculations, which is 3.1. So what is the first question? The first question reads, the topographical map or orthophoto map is a smaller scale. Remember, our general rule is the bigger the number, the smaller the scale. The smaller the number, the larger the scale. So if you look at the two, that is your topographical and your orthophoto map, which one is smaller scale and which one is larger scale? So from the options that we are given, you can see that your topographical map is your small scale map. Remember, the bigger the number, the smaller the scale. Topographical map, you've got a scale of 1:50,000, and your orthophoto map, you've got a scale of 1:10,000. So the bigger the number, the smaller the scale. The smaller the number, the larger the scale. So our answer here is topographical map. Is topographical map. Then 3.1.2, a small scale map shows. Remember, our small scale is for a large area and it's less details. It does not give a lot of information. It's for a larger area and it's less details. Whereas our large scale is for a small area and it is great detail. So our answer for 3.1.2 is D, which is your larger area and less details. That gives you D as the answer. Then 3.1.3, it reads the grid reference of the reservoir F in B1 on the topographical map. Our reservoir F in the topographical map on B1, this is where we've got our B. We are talking about the reservoir that is here. So what you do now, if you want to, you can use a game of elimination. You look at the options that you have here. What are the options that we have? We have got 2610. If you look at your latitude, it is starting with a degree of 29. What is starting with a degree of 26 is your longitude, which means A is out. Okay? Then you move on to the next one, 29. If you look at your latitude here, is 29 degrees. It's starting at 01, then 02. So if you check where your B1 is, this square is 02 minutes. So it's 29 degrees, 02 minutes. If you can check what else is called 02 minutes. So there is B is correct. B is correct, which means your answer there is B. I've just used the concept of elimination, looking at my answer and also looking at the exact location of my reservoir. So if you look here, this is 01, it ends here. Then 02 starts, it ends where 03 starts. So our reservoir is slightly below 3, which is still under 2 minutes. That is 29 degrees, 02 minutes, 55. I'm not going to do the calculations, but obviously this is the only option that is correct. If you compare with the option that is given on C, which is 2901, is wrong. So our answer is B. Then 3.1.4, it reads determine the true bearing of the spot height 143186 in block A3 from spot height 142787 in block DB4. So when you look now at your map, you can see that we are going to use an orthophoto map. We are using an orthophoto map. We are using an orthophoto map. So what we are going to do now is we are going to locate our spot height from the orthophoto map, because here is written from the orthophoto map. We are going to locate our spot height from the orthophoto map in A3. This is 1431 A3, where we have got our 6. Then we are also going to locate from spot height 1427 at 7 in block B4. Where is our B4? Our B4 is here. So what you need to take note of is where it says from, which means I'm going where my 147 is. This is where my 147 is. What I'll do is I'll draw a perpendicular line that passes through the point 7 here. Okay, I identify my true north. I also do the same thing here. I identify the spot height, the 2 point, which is 1431, which is here. What I'll do next is I will join the 2 points. I will join the 2 points. So I've got my 2 points. I've got the spot height, which says from, which is 1427, and 2, the 1434. So I'm going to measure my true bearing now in a clockwise direction. I'll read the question again and try to make sure that you understand what exactly is required. So it reads, determine the true bearing of spot height 1431. This is 1431, okay? In block A6, in block A3, which is 6, this is the number. From spot height 147 at 7 in block B4, this is the number. So this is the spot height that is referred to as from, and this is the one that is referred as to. So I go where it says from, I draw a line that passes through spot height 1427. This is what I've done so that I can identify my true north. I join the 2 spot height points as given, which is from here up to there. Okay, so I'm going now to measure my true bearing in a clockwise direction from here up to there. That's what I'm going to do, which means I'll need my protractor. This is my protractor. I'll place it here. Obviously, I already know that a straight line gives me 180 degrees. So already a straight line gives me 180 degrees. I'll write my 180 degrees. Okay, so it means I need to measure the other side now. I'm going to take my protractor. I'll do the same thing from the center. Why do I have? I'm going to measure from here up until where I've got this line that connects 1427 to 1431. What do I have? I've got something like 130, 135. So I'll have my 180 plus 135 degrees. So if I add 180 plus 135, what am I going to get now? 180 plus 135. What is my answer? I'll get something like 315, which means the answer is 315 degrees. That will be my answer. So if I go here, it means my true bearing is 315. How did I get that? I identified the 2 points, that is my 2 spot heights, 1431 and 1427. I identified the one that says from, which is 1427. I drew a line that passed through the spot height 147. I identified my true north. I joined the 2 spot height, that is 1427 and 1431. Then after that, I measured in a clockwise direction, which means from here until there. The straight line here gives me 180 degrees. The straight line here gives me 180 degrees. Okay, then I wrote my 180 degrees. Then I also measured here to make sure that I've got the correct recording. So from here up until where I have my line, I've got 135. So if I add my 180 plus 135, I've got 315 degrees. That's how I got 315 degrees. Then the next question reads 3.1.5. Calculate the average gradient of spot height. I'm using a topographical map now. Calculate the average gradient of spot height 1358 at G. 1358 at G. This is where we are at 1358 at G. And in block A3, this is your block A3, 2358. And the trigonometrical station 96 at H in C4. H in C4. This is our H is, where our H is. So you are given 2. This is the beacon number, mind you. 96 is the beacon number, which is here. The height that is there is 144. So I've got 2 heights here. I've got 13. I have 14. I've got 1358. Remember, this is in meters. Then at H, what do I have at H? At H, if you can see here, I have got the beacon number 96, which is my height is 1455.6. I've got 1455.6. This is what I have in meters. So, what information am I given? I'm given this spot height. Then this 96, I've got a height of 1455.6. This is in meters. Use the following information. The distance between spot height 1358 and the trigonometrical station 96 is 7.8, which means the distance between these two given points, it is 1368 and 1455.6. I've been given the distance. The only thing that I need to calculate is the vertical interval. I've been given the distance, which is 7.8 centimeters. So what I'm going to do now is I'm going to use my formula. My formula now is my gradient is equal to VI over horizontal equivalent or horizontal distance. What is my vertical interval? My vertical interval, I'm given 2 heights. That is 1455.6 minus, what else do I have? I've got 1358. So I've got these 2 heights that I'm given. This is for the trigonometrical station and this is for the spot height. So I'll subtract, okay? This is the bigger height, which is 1455.6, and this is for the spot height. So I'll subtract and see what I'm going to get there. So you can see, what did I get? I've got 97.6. So it means my VI is 97.6. Remember, this is in meters. Then from my horizontal distance, I'm going to get the information that I'm going to use the information that I've got here, which is 7.8, which means my horizontal equivalent has already been measured in terms of the distance on the map. It's 7.8 centimeters. Which map am I using? I'm using a topographical map, and I want my answer to be in meters, okay? So I'm going to say 7.8 multiplied by 500 meters, okay? 7.8 multiplied by 500 meters. Why am I multiplying by 500 meters? Because I want my answer to be in meters. So it's 7.8 multiplied by 500 meters, okay? Which means I'll have 97.6 meters over 7.8 multiplied by 500. I'll get 3.9, which is 3,900, both in meters. So what I'm going to do, I have got now 97.6 meters over 3,900 meters. I'm going to divide both by the VI, which is 96.7. So I'll get 1, then I'll say my 3,900 divided by 97.6. What do I get? I have 39,959, okay, which is 1 over 39.96. I do not leave it as a fraction. I'm supposed to write it as a ratio expression, which is 1:39.96. That will be my gradient. So that will be my gradient. So from the information that I have, I was given the distance, which is the horizontal equivalent in centimeters. So what I've done is I have multiplied my horizontal equivalent on the map in centimeters, multiplied by 500 meters. Why? Because I'm using a topographical map. I've changed my 50,000 centimeters into meters, and it gives me 500 meters. The vertical interval, I have subtracted the height of the trick beacon, which is 1,455.6, minus the spot height, which is 1,358. That's how I got the 96.7. I divide both by the vertical interval. Then I got 1/39.96. Then I expressed it as a ratio, which is 1:39.96. That is my answer for the gradient. That is my answer. Remember, gradient is not written in units. You just write it the way it is. Then, is the gradient steep or gentle? Remember, when you talk about the steepness or the gentleness of the slope, that's our gradient. If it's less than 10, it's what? It's steep. If it's between 10 to 15, it's moderate. If it's 15 plus, then it's gentle. Let's look at our number. It's 39, which means is gradient. The answer here is gentle. Then from there, why did this gradient in question 3.1.6 be an advantage for road construction? So when you're looking at road construction, what is it that we expect when it comes to road construction? I think that's what you should ask yourself. What type of slope or favors road construction? So you can see, number one, it's cheaper to build. That's number one. It's easier to build. You can talk about that. It's safer to build. There's no need for tunnels or paths. Why? Because it's gentle. That's basically what we are talking about. It's favored by the gentleness of the slope, which is part of our gradient. So the answer would be it's cheaper to build, it's easier to build, it's safer to build. These are the answers that you can consider in as far as number 3.1.7 is concerned. Why would this gradient be an advantage for the road construction? So just to do a recap, 3.1.1, we have said that it's topographical map. Why? Because the bigger the number, the smaller the scale. Then for number two, a small scale, what does it do? It's for a larger area and is less detailed. Then, which means your answer is D then. Then for 3.1.3, we have looked at our map, and by just looking at our map, B1, which means there is 01 minutes 29, 02 minutes. If you check the answers that we have here, you can find that this is where our reservoir is. So it means our answer is 2902. Which other option has got 2902? It's only B. That is our answer. To determine our true bearing, you see what we have done. We have looked at the two given points, that is the spot height from our topographical map. This is 1431 and 1427. 1427 is the one that they are saying from. So you go there, draw your line, identify your true north, join the 2 points, which is the spot height, then you measure clockwise. That's how we got our 180 from a straight line plus the 135 to give us 315 degrees. That is our true bearing. Then from there, our average gradient, we are given information in relation to the horizontal equivalent, which is 7.8. So you just multiply that 7.8 multiplied by 500 meters, you get 3,900. For you to get your vertical interval, which means you're looking at which one is the highest height between the two. Our trigonometrical beacon has got the highest height, which is 1,455.6 minus 1,358. Then you get 96.90. You get your 97.6. So you divide both by the vertical interval, then you get 1:39.96. That will be your gradient. Then here, like I've emphasized, this is how you analyze your gradient. Less than 10 is steep, 10 to 15 is moderate, then 15 and above is gentle. So it means our answer is gentle. Then lastly, obviously, we have said that the reason why it is suitable for road construction is because it's cheaper to build, it's easier to build, safer to build, and there's no need for tunnels.